Welcome back to my YouTube channel. I am now talking about variable creation and a math assignment in R. Okay? So if we just type a number, like the number 5, it simply prints out the number 5, which is not very helpful and probably not what you want to do. Most likely you want that number to be saved somewhere. And that's what assignment's all about. So we have a variable x, and we want it to take on the value 5. So to do that, one way is to make a arrow pointing left to the x and type the number. And when we do that, a variable created, we have the variable x and the value of 5. And if I do that, it prints 5. So wherever I put an x, it retrieves that value of 5. I can also use an equal sign to do the exact same thing. I tend to prefer the arrow over the equal sign because the double equal sign also holds meaning and it does something entirely different. I prefer my assignment to be an arrow, and just generally don't use the equal sign for assignments. Of course, I say that, but I probably will sporadically as we go through programming. I say I use the arrow, but honestly, I kind of use them interchangeably. Okay? Now that I've essentially lied to you and told you about it, let's keep going. Okay. So, yep. We can update information. So I say x equals 5, and I say never mind, x equals 4. That gets updated and still says 4. So it updates right in place. Okay. Now let's say we want not a single value in x, but a string, or what I would call a vector of values, or I guess a group of concatenated values, although I probably would never actually use the word concatenate. Okay, so we have the same setup of assignment. We have the variable on the left and the arrow sign pointing to that variable. We have the C function that stands for concatenate, and a collection of numbers. 1, 2, 3. And when I do the assignment, it gets stored as a vector of numbers, a one-dimensional vector. The first element 1, second element 2, third element 3. And when I print that, you'll see that. But we're not limited to numbers. We can also have it be character values. And as I use that equal sign, I show that I, too, am not the most consistent. I try to use arrow, but I end up using equal sign, not even thinking about it. Okay. So we have the y vector filled with cat, dog, monkey. And we can also concatenate those two vectors into a new vector, xy string, as I called it, c, x comma y. And we have a vector of length 6. First element 1, second element 2, third element 3, cat, dog, monkey. Notice that when I added the character value, the whole vector became a character vector. So that 1 is not being treated as numeric, it's being treated as the text 1. It's not a number to it, it's simply 1 in text. Okay. So we have a few helpful functions that will make your life a little bit easier that I use all the time. So let's say I want to make a vector of the same element. So I have the word cat. I want a vector of the word cat 10 times. So I have two options. I can do times, or just know that the argument there in the second place is times. Doesn't really matter. So I have an arbitrarily long vector cat. I could have just easily made it 1 billion and 10. It just makes your life easier. Okay. Now what else we got? Oh yes, we can put that together with the C function, rep cat, and here I'm gonna not use the time argument explicitly, but I just know the order of the function, and that's it. So cat and dog 10. Okay, so I have a vector of length 20. Half of them are a cat, half of them a dog, just like I wanted for some reason. Okay. And I printed out in the book for some reason also. Okay, the next one is really good. The seek function. So, seek. Oh, I can't use sequence as my name, because if I do that, I'm trying to assign it as a function, and it's not going to be happy with me whatsoever. So you can't use function names as variable names, and that's why here I did this, my sequence. So let's say I want the numbers 1 through 10 by 1. Yeah, I really don't do a good job of naming arguments. So the first one, from equals 1, 2 equals 10, and by equals 1. You could have also done what I did in the book, 1, 10, by equals 1. I would recommend specifying by, because there's another option in the sequence that I find myself using, and it's called length dot out, and that you get a vector of a specified length. If we're counting by 1, we really don't need to think about that. But let's say I want 48 of these. I couldn't conceive of what I'd need to count by to get 48 elements in this vector from 1 to 10. And of course I could figure it out, but I don't want to. That's not a good use of my time, and R will do that for me. It will print that right out and be happy to do it. Okay. Of course we can also do the by a different number, the by 2, and we get a sequence of odd numbers. So in the special case where we're counting by 1, there's actually an easier way to do it that I would pick over what I just did, simply because you're going to be doing it a lot, and there's no reason to write out the sequence function. You can just do 1 through whatever integer value, so the integer is 1 through 10, that's going to default count by 1, and it's separated by a colon, and my simple sequence will give you what you want. It's really helpful for loop where you just need to go from integer value 1 to n, or whatever your highest number is. Okay? Now we have, so far we've only talked about one-dimensional objects, and now we're going to be making two-dimensional objects. Okay? Now, you might be tempted to call your matrix, but remember the matrix function, and you can't do that, or it gets really mad at you. Because then you're trying to overwrite the matrix function, and you may be able to do that, but you definitely don't want to. Okay, so I'm going to not bother with the seek function, because that's kind of silly. So I got matrix values, just like in the book, and I want to arrange these values into a matrix. So a two-dimensional object, rows and columns, and I'm not going to bother assigning it, so I'm just going to print it right here anyway. So there's matrix values, and in row equals 3, in column equals 3. So I specified by row before, and doing so made it print 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I don't specify by row, it goes the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it very much depends on what you intend to do. I prefer to have it go by row. And that's entirely arbitrary, and it's really more so what you need doing with it, of course. Whatever. Oh, I talk about that in the next section. Okay? You're gonna very often want to make an empty matrix, and you can do that simply by specifying 0, so one value, and it's going to get repeated in every element. So in row equals 3, in column equals 3, and it's going to get repeated every time. When you're running for loop and generating data, it's helpful to fill in the elements of the matrix. Okay, so what am I doing here? Oh yeah, I understand what I'm doing here. Okay, so there's other ways to make a matrix that's not that. When you're combining data. So I'm just gonna 1 through 9. That's x, and my factor. I'm using all these tools I just talked about. Low income, why not? And we're not going to assume balance here. We're going to say there's more low income than high income. And honestly, that has more to do with the fact that I said 9 and not an even number. Okay. So, I want to make a matrix out of those two values. I can do that by using cbind. Cbind versus the two factors I specify as columns of a new matrix. So data mat. Okay, so one column is that one vector, and the column right next to it, the other vector. As you'd expect. I had another option. I could have used rbind, And that would have arranged it the other way, where each row is one of the vectors in the R bind. So column 1 is element 1 of the X vector and element 1 of the factory vector. And it depends on what you want to do. If you want to construct a matrix, I'd more often use C-bind, but I have used R-bind too. And I talk about that right here. Yeah. Okay, and we also have something called a data frame. And a data frame has some special properties to it. So I want my data frame to turn a matrix into a data frame. You use data dot frame. And I'm just going to go ahead and put it back in the C-bind form, because I prefer that rather than X, comma, factor, and have it as R-bind. Okay, data frame. Okay. Do I talk about the special properties of a data frame? Oh yes, I actually didn't need to use C-bind. I could have done X, comma, factor. So that was unnecessary. And I actually talked about what I was thinking about later on, so I'm going to hold off and get to list. Because I think that I should do it in the book and teach in that way. Okay. So if I want a list, I can't name it list, or get mad at me. 1, 2, 3, out in the book, in a matrix. Okay, and I'm printing this list. So what I input, the first thing I put into the list function was a vector of length 3, the numbers 1, 2, 3. And then the second thing I put into the list function was a matrix. So this is actually its own special data object, appropriately named a list. And it can hold R elements of dissimilar type. It does not. You can put a list in a list, you can put a vector in a list, you can put a matrix in a list, you can put a data frame in a list, you can put an array in a list, and I don't think I even talk about arrays. You can put anything in a list. It's a preferred method of output for functions. If you run a regression model or something to that, it will very often put the results in a list. Your function can only output one thing, and when you have a bunch of different data types you need to output, that goes in a list. Okay. Oh, you can also add to a list. And I don't know if I even talked about that in any other way, but we're adding stuff to a list. Okay. So we filled the first and second elements of the list with a vector and a matrix. So I want to fill the third element. So all I do is specify the element tree. In normal subsetting, you do one set of square brackets. In this list subsetting, you do 2. Okay, and then I do my regular assignment arrow, and I am a programmer. And then when I print the list again, I have that same list but with a third element with the factory I am a programmer. Okay. Oh, and I talk about some methods of generating random data. I love generating random data. Okay, so normal draw. By the way, variable names can't have spaces. That's why I do underscores. So our norm, and like I said, either in this video or a past video, I'm not specifying in. So the first argument and the only required argument in. The number of samples I want to take from the normal distribution, with mean 0, standard deviation 1, which is also called a standard normal. Okay, I can go on to specify the mean and standard deviation, and I'm not going to make a fancy name like I did in the book, because that's a waste of time right now. Okay, so our norm, same deal. I want 10 draws. The mean is equal to 10, and SD equal to 2. And I'm only now realizing I was really inconsistent. I never named n, but I named mean and standard deviation. Whatever. Okay, and it prints the data. Okay, so the set seed function allows you to reproduce your random draw simulation. So if I run your code with the same seed, I'm going to get the exact same random number. So maybe I should go ahead and make a point to show you what happens when you don't set the seed. Okay, so our norm n equals 10. I run the same line, I get different numbers. Every time I run this code like that, I will get different numbers. But if I set seed 1, 2, 3, and I'm going to write this on the same line so I can forward it back up easily. The semicolon allows you to write two functions, two little pieces of code on the same line. It's probably bad practice for teaching, but I'm going to do it right now. Okay, so I have the seed set to 1, 2, 3, our norm 10. And if I do the same thing, it's always going to be that. It was like this in 2019 when I wrote the book, and it's like this now. So set.seed does that. It allows your code to be reproducible, so the results you get will be the same results I get. Okay? So in the next video, I'm going to go over working with our objects, subsetting them, and manipulating them. Okay, that's the end of the video. Thank you for watching.